Hello guys, how are you all? I hope you all are fine. So you are very welcome in a lecture number 7 of areas of parallelograms and triangles. Okay, so now I hope you will enjoy this lecture. So let's start without wasting the time. Yes, so here is today we are going to discuss important results. Okay, so now here is the result is what? Diagonals of a parallelogram. Here we have a diagonals like A, B, C, D. Okay, we know that diagonals of a parallelogram divides into two congruent triangles. Okay, if so, here we are going to see that diagonals of a parallelogram divide it into. We are talking about the both diagonals. Okay, divide it into four triangles of equal area. Okay, it means the diagonal AC and DB divides this parallelogram into four triangles of equal area. This is very important. We have to prove this condition. Okay, I hope you understand these things, my dear friends. Yes, so now let's prove this. Yes, so now let's prove this. Okay, so here is first of all we have to write the given part. So what is the given part? So my dear friends, we have a parallelogram. We have a parallelogram A, B, C, D. Got it? With diagonals, with the diagonals AC and DB. With diagonals AC and DB. Okay, and we have to prove we have to prove, you can see area of triangle AOB, which is equals to area of triangle BOC is equals to area of triangle COD is equals to and area of triangle AOD. Okay, means the area of this triangle and the area of this triangle and the area of this triangle. So all these area of this triangle are equal. Okay, 1, 2, 3 and 4. So we have four triangles of equal area. I hope you understand these things, my dear friends. Now let's start. Here is proof. Okay, so now in this case, my dear friends, we know that ABCD is a parallelogram. ABCD is a parallelogram. Okay, and diagonals of a parallelogram bisect each other. We know that means diagonals of a parallelogram bisect each other. Got it? So you can see here is it means we can say that this point O is the midpoint of BD. Okay, and as well as AC also. Okay, so here is we can say that so O is the midpoint of BD. Okay, and AC, that is we can write what OB is equals to OD. Okay, and OA is equals to OC. So here we can write OB is equals to OD. Let's suppose this is equation 1. Okay, and OA is equals to OC. Let's suppose this is equation number 2. Okay, now in triangle ABC, here is in this triangle A, B and C. Okay, we know that AO is equals to OC from equation number 2. Okay, so in triangle ABC, OA is equals to OC from equation number 2. Okay, and BO is what? BO is the median. BO is the median of triangle ABC. So BO is the median because BO line divides AC into two equal parts. So we can say BO is the median of triangle ABC. And we know that the area of triangle AOB, okay, is equals to the area of triangle BOC because the median, yes, because the median divides the triangle into equal areas. Okay. Yes, so we can write here as area of triangle AOB is equals to area of triangle BOC. We can write the reason. What will be the reason? Median divides the triangle. Median divides the triangle into equal area. Okay, my dear friends, I hope you get this one. Now let's suppose this is equation number third. Okay. Now in triangle ADC, means in this triangle we are taking this triangle. Okay. So in triangle ADC, here is again we can write OA is equals to OC from equation 2. Okay, and so we can say DO is the median of triangle ADC because DO divides the line AC into two equal parts. So we can say DO is the median of triangle ADC. Okay, so again we can say that area of triangle AOD is equals to the area of triangle COD, means area of triangle AOD, okay, and the area of triangle COD are equal, means the third reason and the fourth reason. Okay, the reason is same as in the previous, like median divides the triangle into equal area. Median divides the triangle into equal area. Okay, and let's suppose this is equation number 4. Okay, now similarly in triangle, here is ABD. Now in this case we are taking the triangle like this. We are taking this triangle ABD. Okay, and our main target is to prove the area of triangle reason 1 is equals to the area of triangle of reason 4, means area of triangle AOB is equals to area of triangle AOD. We have to prove this. Okay, so in triangle ADB, got it. Here is, we know that OB is equals to OD. OB is equals to OD from equation number 1. Okay, and so we can say that AO is the median. AO is the median of triangle ADB. Okay, because here is, you can see AO. Okay, AO divides the line DB into equal parts. DO is equals to OB. Okay, so we can say AO is the median, and we know that area of triangle AOD is equals to area of triangle AOB because this median divides the triangle ADB into two equal area. Okay, so the reason is median divides the triangle into equal area. Now let's suppose this is equation number, this is equation number 5. Okay, so from equation third, from fourth, and from fifth equation, we can write as area of triangle AOB is equals to area of triangle BOC is equals to area of triangle COD, which is equals to area of triangle AOD. Okay, it means the area of triangle AOB is equals to area of triangle BOC is equals to area of triangle COD and is equals to area of triangle AOD. Okay, so this is our what? This is our required result. This is our required result. So we can write and prove. Okay, so I hope you understand these things, my dear friends. Yes, now let's move on. Yes, so now let's solve some problems. Okay, so here is in this question, in figure, diagonal AC and BD of quadrilateral ABCD. Here is this diagonal. We are talking about this diagonal AC and BD of quadrilateral ABCD. Okay, intersect at point O. Okay, these two diagonals intersect at point O such that OB is equals to OD. It means this line OB is equals to OD. Okay, and AB is equals to CD, means AB is equals to CD. Okay, now we have to prove. Then show that area of triangle DOC is equals to area of triangle AOB. Area of triangle DOC means this part is equals to area of triangle AOB means this part. Okay, and in the second case, area of triangle DCB means this complete area of triangle is equals to area of triangle ACB means this. Okay, and the third is DA is parallel to CB. DA is parallel to CB, or ABCD is a parallelogram. Okay, now the hint of this question is this: from point D and B, draw a perpendicular to AC. Draw a perpendicular to AC means like this. So this is the hint to solve this problem. Okay, so now let's solve this problem. So here is, first of all, we are solving the part 1, and here we have to prove area of triangle DOC is equals to area of triangle AOB. Got it? So now let's start. Yes, so now first of all, here is, let's write the given part. Okay, so here is, we have a quadrilateral ABCD. Okay, and here is OB is equals to OD and AB is equals to DC. Okay, and we have to prove, here is, we have to prove area of triangle DOC. Area of triangle DOC is equals to area of triangle AOB is equals to area of triangle AOB. Okay, means this area of triangle DOC means this area is equals to the area of triangle AOB means this part. Okay, so for this, let's start to prove. Yes, so now first of all, let us draw the DP. Which is perpendicular to AC, and BQ which is perpendicular to AC. Okay, so here is, let us draw DP which is perpendicular to AC and BQ which is perpendicular to AC. Okay, I hope you get this point. So now in triangle DOP, here is, we are talking about this part DOP, this part 1, Okay, and triangle BOQ means we are talking about this part BOQ. Here is angle DPO is equals to angle BQO. This is equals to what? 90 degree. This is equals to 90 degree. Okay, and angle DOP means angle this DOP is equals to angle BOQ because they are what? Vertically opposite angle. And here is the third part is the third condition is OD is equals to OB. So this is what this is given. So we can say that the triangle means we can say that the triangle here is DOP is congruent to triangle BOQ. Okay, these two triangles are congruent by what? By angle side rule. By angle side rule. Okay, so that we can say that here is we can say DP is equals to BQ means these altitudes or these perpendicular lines are equal by what? By CPCT. By CPCT. Okay. Yes, so now we can say that DP is equals to BQ by what? By CPCT. By CPCT. Let's suppose this is equation number 1. And also we can say that area of these two congruent triangles are equal. So area of triangle DOP is equals to the area of triangle BOQ. Okay, and let's suppose this is equation 2 and we can write the reason of this part is we know that area of congruent triangle triangles is equal. Got it, my dear friends? Yes, so now here is now in triangle here is you can see in triangle CDP. In which triangle? In triangle CDP means this part. Okay, and in triangle ABQ means this part. Okay, so in triangle CDP and triangle ABQ. Here is again we can say that angle CPD is equals to angle AQB. This is what? This is 90 degree. Both the angles are what? 90 degree. Okay, and CD is equals to AB. This is given in the question. Okay, and here is DP is equals to BQ means this line is equals to this line from equation number 1. From equation number 1. So we can say that triangle CDP is congruent to triangle ABQ. Is congruent to triangle ABQ. Okay, so here is by what? By now you can see here is a right angle. Okay, and a hypotenuse which is this and one side. So we can say these two triangles are congruent by RHS rule. By what? Yes, by RHS rule. Means right angle, hypotenuse and a side. Okay, so here is we can say that these two triangles are congruent. So area of triangle CDP is equals to the area of triangle ABQ. I hope you get this point because area of congruent triangle is equal. So here is, let's suppose this is equation number 3rd. This is equation number 3rd. Now add equation 2nd and 3rd. Okay, so here is we get, if we add these two equations, so this will become area of triangle DOP plus area of triangle CDP is equals to area of triangle BOQ plus area of triangle ABQ. ABQ. Okay, so if we add this area and this area, then we get area of triangle DOC. Okay, and if we add this area and this area, then we get area of triangle AOB. So this will become area of triangle DOC is equals to area of triangle AOB. Okay, so this is a what? This is a required result, and we can say hence proof. I hope, my dear friends, you understand these things. Yeah, so now let's move on. So here we have to prove area of triangle DCB, means this part, area of triangle DCB. Okay, it is equals to area of triangle ACB, means this part. So we have to prove, yeah, these two triangles, the area of these two triangles are equal. Okay, so now let's see that. So here in part 1 we proved that area of triangle DOC is equals to area of triangle AOB. Okay, here is, if we add in this equation, if we add area of triangle OCB, okay, if we add in this equation area of triangle OCB, then this will become, then in this, if we add area of triangle DOC plus area of triangle OCB, then this will become area of triangle DCB. Okay, and if we add this part in this equation, in this triangle AOB, so this will become area of triangle ACB. Okay, so here is you just have to understand the concept of this part. Okay, so area of triangle DOC plus here is area of triangle OCB, okay, is equals to area of triangle AOB plus area of triangle OCB. Okay, so here is we are doing adding area of triangle OCB in both sides. Okay, so this will become, this part will become, here is area of triangle DCB is equals to, and this part will become area of triangle ACB. I hope, my dear friends, you understand these things. Okay, so we can say that hence proof. We can say hence proof. Okay, yes, so now let's move on. Yes, so now in the third part we have to prove that DA is parallel to CB, means this line DA is parallel to CB, and or ABCD is a parallelogram. So here is in the part second, in part second we proved that area of triangle DBC is equals to area of triangle ABC. Okay, means we already proved that these two triangles, the area of these two triangles are equal. Okay, so these two figures, these two triangles are on the same base and the area is equal. So by the theorem 9.4 we can say that AD is parallel to BC. Okay, and here is, we know that two triangles on the same base and equal areas, so they lie between same parallels. So we can say here is, so here is triangle DBC and triangle ABC are on the same base. Same base is what? Same base is BC and are equal in area. Okay, so yes, so we can say that. So we can say these triangles lie between the same parallels, which is DA and CB. So we can say DA is parallel to CB. DA is parallel to CB. Okay, I hope you understand these things, my dear friends. Okay, so here is DA is parallel to CB. Yes, so now here is we have to also prove that ABCD is a parallelogram. Okay, now in triangle DOA and triangle BOC, here is in triangle this DOA and triangle BOC. Here is angle DOA is equals to angle BOC because they are what? Vertically opposite angle. And angle DAO is equals to angle BCO. Okay, here is angle DAO means this angle and angle BCO means this angle. They are alternate interior angles because we know that AD is parallel to BC. Okay, and the AC is what? AC is the transversal. So we can say that these two angles are equal because they are alternate interior angles. Okay, and here is OD. Here is you can see OD is equals to OB. So this is what? This is given. So we can say triangle DOA is congruent to triangle BOC by what? By angle side rule. Okay, so we can say DA is equals to BC means this line is equals to this line by CPCT corresponding parts of congruent triangle. Okay, yes, so in ABCD, here is DA is parallel to CB and DA is equals to CB. So if one pair of opposite sides of a quadrilateral is equal and parallel, then we can say that quadrilateral is parallelogram. Okay, so we can write here as one pair of opposite sides of quadrilateral ABCD is equal and parallel. Okay, so we can say that since ABCD is a parallelogram. Okay, and we can write hence proof. Okay, I hope my dear friends you understand these things. Yes, so now let's move on. Yes, so here is the next question is D and E are points on the sides AB and AC respectively. So here is D point and E points, okay, are on the side AB and AC of triangle ABC such that area of triangle DBC means this part, area of triangle DBC is equals to the area of triangle EBC means this part. Okay, and we have to prove that DE is parallel to BC. Okay, so first of all write the given part. Okay, what is the given part? So we have a triangle ABC. Okay, and D and E are points on sides AB and AC, such that area of triangle DBC is equals to the area of triangle ABC. Okay, and we have to prove DE is parallel to BC. So now let's start to prove this. So this is the proof. So my dear friends, here is triangle DBC and triangle EBC. Means triangle DBC and triangle EBC are lying on the common base, which is BC. Okay, and have equal areas. Okay, and they lie between the lines DE and BC. We can write it by the theorem. So DE is parallel to BC. So we can write the triangle DBC and triangle EBC are lying on a common base, BC, and have equal areas, and they lie between the lines, DE and BC. So we can say DE is parallel to BC. Okay, because two triangles having the same base and equal areas lie between the same parallel. So we can write hence proof. Okay, so this is very easy question. Yes, so now let's move on. So here is, in the next question, the side AB of a parallelogram ABCD. Here is, we have a parallelogram A, B, C, D. So this is the parallelogram. So it is saying that the side of AB is produced to any point P, means this is produced to point P. A line through A, and parallel to CP, means parallel to this CP. Okay, produced at Q, means like this. Means we can say that AQ is parallel to CP. Okay, then parallelogram PBQR, means this parallelogram is completed. Now show that area of parallelogram ABCD, means this part, is equals to the area of parallelogram PBQR. Okay, so here is a hint. Join AC like this, and PQ, means like this. And now compare area of triangle ACQ, means this triangle, and area of triangle APQ. Okay, I hope you get this point. Yes, so now let's start. Yes, so now my dear friends, first of all let's write the given part. Okay, yes, so we have a parallelogram, which is A, B, C, D. Here is A, B, C, D. This is, we have a parallelogram. Okay, where CP is parallel to AQ, means this CP is parallel to AQ. Okay, and we have another parallelogram which is PB Q R. Okay, so PBQR is a parallelogram. Means this PBQR. So we have two parallelograms. Okay, and we have to prove here is, and we have to prove area of parallelogram ABCD is equals to the area of parallelogram PBQR. PBQR. Okay, yes. So now, first of all, we have to do a construction. We have to do a construction. Okay, so what is the construction? So you can see. Okay, yes, here is, we have to join AC. Okay, means we have to join AC, and we have to join also PQ. We have to join PQ also. So we can write join AC and PQ. Okay, yeah. So now let's start to prove this problem. So here is, now for triangle ACQ and triangle AQP. Here is, you can see ACQ means we are talking about this triangle ACQ. Okay, and AQP means this triangle AQP. Okay, we are talking about these two triangles. Okay, so these two triangles are on the same base, AQ, and between the same parallel lines we have AQ is parallel to CP. Okay, so we can say that the area of triangle ACQ and the area of triangle AQP are equal. Okay, so we can say triangle ACQ and triangle AQP, they are on the same base. You can write on the same base, which is AQ. Okay, and between the same parallel lines, which is AQ and CP. Okay, and we know that triangles with the same base and between the same parallels are equal in area. So we can write area of triangle ACQ is equals to the area of triangle AQP. I hope you get this point, my dear friends. Yeah, so we can write this is by theorem. Okay, by theorem 9.3. I hope you understand these things. Yes, so now subtracting it is. Subtracting, you can see the triangle ABQ is common in both the triangle. So we can say that we can subtract this common triangle from both the triangle. Okay, so we can write subtract area of triangle ABQ both the side. So this will become area of triangle ACQ minus area of triangle ABQ is equals to area of triangle AQP minus area of triangle ABQ. Okay, so after subtracting we get, here is on the LHS side we get area of triangle ABC. We get what? Area of triangle ABC. Okay, and in the RHS we get area of triangle PBQ, means this part and this part. So here we get area of triangle ABC. Okay, which is equals to area of triangle PBQ. Now let's suppose this is equation number 1. Okay, now in parallelogram ABCD, we know that AC is diagonal. Means this AC is diagonal. Okay, and this AC, this diagonal, divide this parallelogram into two congruent triangles, which are triangle ABC is congruent to triangle ADC. Okay, so we know that diagonals of a parallelogram divides it into two congruent triangles. We can write diagonals of a parallelogram divides it into two congruent triangles. I hope, my dear friend, you understand these things. So we can say that if the two triangles are congruent, then the area of these two triangles are also equal. So we can write area of triangle ABC is equals to area of triangle ADC, which is also equals to half of the area of parallelogram ABCD. Half of the area of parallelogram ABCD. Let's suppose this is equation number 2. Okay. Now in parallelogram PBQR means in parallelogram PBQR. Here is again this PQ diagonal divide this parallelogram into two congruent triangle. Okay. Yes. So in parallelogram PBQR. Okay. PQ is what? PQ is diagonal. PQ is diagonal. Okay. So we can say triangle PBQ is congruent to triangle PRQ. Is congruent to triangle PRQ. Okay. So again the reason is same, which is diagonals of a parallelogram divides it into two congruent triangle. Okay, so we can write here is area of triangle PBQ is equals to area of triangle PRQ. Okay, here is, we know that area of congruent triangle is equal. Okay, so we can write again area of triangle PBQ is equals to area of triangle PRQ. Okay, which is also equals to half of the area of parallelogram PBQR. This is equation number 3. Okay, and here is from equation number 1 we know that area of triangle ABC is equals to the area of triangle PBQ. Okay, so here is, you can see in this means area of triangle ABC is equals to, okay, here is area of triangle PBQ. Okay, and these two triangles are equals to the half of area of parallelogram ABCD, and this is equals to half of area of parallelogram PBQR. Okay, so my dear friend, from equation 1 we know that area of triangle ABC is equals to area of triangle PBQ. Okay, and area of triangle ABC is equals to what? From 2 we can say that this is equals to half of the area of parallelogram ABCD. Okay, and the area of triangle PBQ is equals to what? From the equation that it is equals to half of the area of parallelogram PBQR. Okay, so this is equals to half of the area of parallelogram PBQR. Okay, and from this half, yes, this half and this half will be cancelled, so we get area of parallelogram ABCD is equals to area of parallelogram PBQR. QR. Okay, yeah, so we can write hand proof. Okay, I hope you understand these things, my dear friend. So this is enough for today. Okay, and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me, and take care and goodbye.